Welcome to the second half of our lesson on quadratic functions. We are now connecting to college algebra. Looking at number 1 and number 2, these given quadratic equations are a little different. In number 1, we are in the vertex form, or the y equaling a times x minus h squared plus k. The only place where we're a little bit off is needing the minus sign in the parentheses, which we can fix by changing addition to the subtraction of a negative number. Once in this form, we have our minus sign in the parentheses and our plus sign on the end. Therefore, we can identify the h value as -1 and the k value as a +3. These two numbers give us the vertex of this parabola or quadratic equation. So the vertex is found to be -1, 3. The a in the front, the coefficient, will tell us if the parabola or quadratic equation, its graph will open up or down. If this number is negative, which it is, it means our parabola will open down. These are the first questions asked, whether the parabola opens up or down and what the vertex is. The remaining questions are intercepts, sketching, symmetry, and max and min. To have a little more space, I'm going to work above the question so that I can still see my equation. Now it asks me, what are my intercepts? Well, my X-Intercepts, or intercept, however many there turns out to be, will be a point where the y value is 0. My given equation is y equaling a -3 times x plus 1 squared plus 3. If I replace the y value with 0, I will then need to solve for x. To solve for x, I would want to subtract this 3 off the end to the left side of the equation. Then I would divide off the -3. Now I can apply the square root formula, remembering to put the plus minus in front of the radical, giving me two values of a positive and -1 on the left side. This results in two equations. One is x plus 1 equaling the +1, and the other is the x plus 1 equaling a -1. The result is an x value of 0 and an x value of -2. Remember, the goal is to find the x-intercepts, which are points in which the y value is 0. Therefore, the first x-intercept is the point 0, 0, and the second x-intercept is the point -2, 0. I'm also asked to find the y-intercept. The y-intercept is usually a little easier to find because it is with an x value of 0. So again, referring to my equation of y equaling a -3 times x plus 1 squared plus 3, I replace the x value with 0. This will result in a -3 plus 3, or 0. Again, remember, the y-intercept is the point where the x value is 0, and I have found the y value to also be 0 to match it. So my x-intercepts, there are 2 of them, and I have one y-intercept. I am also asked to sketch this function. This is not always easy on a tablet. I will do my best. My vertex is the point -1, 3, My x-intercepts occur at the origin and the point -2, 0. My y-intercept is also the origin, and I know my parabola opens down. There's a rough sketch of my parabola, also the graph of the quadratic equation. It asks me to determine the axis of symmetry. The axis of symmetry is the vertical line that cuts through the vertex, which is a vertical line. So the equation of the axis of symmetry is an x equals equation, and in this case it will be x equaling -1, which is the x value of the vertex. It then asks me to determine the maximum or minimum value of this function. Well, since this function opens down, the vertex is the maximum. So the maximum or the highest point is the vertex, -1, 3. Then it asks to determine the domain and range. In this graph, my domain would be -infinity to infinity from right to left. And my range from bottom to top would be -infinity to a y value of 3 at the vertex. Remember, this is a y value at the vertex. I believe we've answered all questions for number 1. Number 2 will be very similar with the exception of how to find the vertex. So I'm going to explain the vertex before moving on. When you have your equation given to you in vertex form, not vertex form, in standard form, once again your a value is the coefficient of x squared, which is 1, your b value is 4, and your c is 3. If your a value is positive, then your parabola will open up. To find the vertex, we go back to what we learned earlier in this lesson 8, which was the x value of the vertex is -b over 2a. So the x value of the vertex is a -b of 4 over 2 times a, which is a -2. So the vertex is the point in which the x value is -2. To find the y value of the vertex, I take that x value of -2 and plug it back into the equation, x squared plus 4x plus 3. So this will be -2 squared plus 4 times -2 plus 3, which is 4 plus -8, which is -4 plus 3, which is -1. This is the y value of the vertex. So to find the vertex from standard form, you need to memorize the -b over 2a as the x value of the vertex. Let's go ahead and move to the next topic. This is the vertex formula, emphasizing again how to get the vertex when your quadratic equation is given to you in standard form. So just as with the last example, the vertex is found by remembering the x value is -b over 2a. Therefore, if my b is a -48 and my a is 4, my vertex is, the x value of my vertex is going to be the negative of b, which is another negative, over 2a, which is 2 times 4. This becomes 48 over 8, which is 6. So the x value of the vertex is 6. The y value is to plug that known x value of 6 into this equation. So it's 4 times 6 squared minus 48 times 6 minus 20. This is a very large number. Let me pause this a second. And this results in a -164, which again is the y value of the vertex. This is how you find the vertex given standard form. One more question, but this is a rather lengthy question. write this quadratic function in vertex form. In other words, manipulate this equation until it is in the form of y equaling a times x minus h squared plus k. Now this method varies between instructors, so I hope the method I use will look similar to something you have seen in the past. I like to begin by taking it out of function notation and just writing it as a y equals equation. To complete the square and get this quadratic equation into vertex form, my leading coefficient or my a value must be 1. So I divide every term, including the y, by the number 4. Now I need to move the 5 to the left side so only my x's are on the right side of this equation. Now I perform some operations which seem like a little bit of magic off to the side, in which I take 1/2 of the middle term, or the coefficient of x, 1/2 of -12, which is -6, and I square that number and come up with this magical number 36. This lovely magical number 36 I add to each side of this equation to maintain the equality in the equation. The reason I do this is now the right side becomes a perfect square, x minus 6 perfectly squared, getting the -6 from my parentheses while I was performing this unusual operation, which I'm kind of drawing a cloud around. At this point, I need to clean up the left side of this equation. The left side is y over 4 plus 41. And I now want to solve this for y by subtracting the 41 off of each side of this equation. And last but not least, I come in here and I multiply everything times 4 in order to make this equation written as y equals. Now it is in vertex form. Remember, vertex form is handy because it makes it pretty easy to find the vertex. That is the end of this recording. Thank you for watching it to the very end, and I do hope it is helpful to you.